Hello everyone and welcome to another video. In this particular video, what we're going to be looking at is identifying when processes repeat. So we're going to look at repeated processes. So remember, what is a process? A process is an equation or a set of equations or a set of steps that form a process with an input and an output from it. So we're going to identify when these processes can be used over and over and over again in a repeated cycle. The other thing we're going to take a look at is how to make these processes repeat in code or in MATLAB. And for this, we're going to use what's called a for loop. And by the end of this video, what I'd like you to be able to do is to be able to look at the for loop syntax and also look at the for loop implementation in MATLAB. So with that, let's get learning. All right, so what I'd like to do is use an example to motivate this particular repeated process example. So if we count by twos from 0 to 10, we can go 0, 2, 4, 6, 8, 10. And within that counting process, there is embedded in it a process from one step to the next step. So in other words, from 0 to 2, there's a process. From 2 to 4, there was a process. From 4 to 6, there was a process. From 6 to 8, there was a process. And 8 to 10, there was a process that was taken. And that process, in this case, was we added 2 to the previous number. So we took 0, added 2 to it, and we got 2. If we then take 2 and we add 2 to that, we get 4. And if we keep adding 2, we're going to end up at I equals 10. So I'm going to show a pictorial representation of this as a flowchart with all the processes involved in it. All right, so let's get rocking and rolling with this flowchart over here. So this flowchart represents the example of counting by twos. So let's start up here on the flowchart at the start location. That's the start of the program. We're then going to go in and we're going to put an input to begin of I equals 0. So what that's doing is it's initializing the value of I to 0. We then continue down our flowchart to this diamond here. And the diamond, what you can see, has several legs out and several legs in, which means inside of that diamond, there's some kind of a decision process going on. So either we're going to continue down one direction or we're going to go a separate direction from the diamond. And we're going to see this more in the next video. But for now, let's just take this diamond here and recognize that inside of that diamond, it says we're going to do something for 6 repetitions or 6 reps. This is similar to me saying to a bodybuilder, you're going to lift that weight for 6 repetitions. And then they would do 6 curls. 1, 2, 3. And each process or each curl there is a process. So what we're going to do, instead of doing curls, we're going to do math curls, right? We're going to say, let's go around this loop here every time we have to do a repetition. So here we're going to do 6 repetitions of this loop here. So let's get rocking with this loop. So we're going to go into the loop and we're going to print the value of I. In this case, the value of I starts off with a value of 0. So the first thing we print to screen is 0. We go over here and we take the current value of I, which is 0, plus 2, which is going to be equal to 2, and we assign that to be the new value of I over here. So I has been updated to a value of 2. On screen, we have 0 printed. We go over here, we go down this bar again here because we haven't done 6 repetitions yet, so we're on our second repetition. We're going to print the value of I now, which is 2. We're going to go across here, go up here, and then right here, we're going to take 2 plus 2, which is going to equal to 4. So the new value of I is going to be assigned 4. We're going to go in here, and now we've done 2 repetitions. So we're going to do our third repetition. We're going to print a value of 4. We're going to go across here. We're going to take the value 4, add 2 to it, and get 6. So the new value of I is 6. We're going to go back in here and start our fourth repetition. So fourth repetition here. We're going to print a value of 6 here, because that's what I's value is currently. Go across here, take 6 plus 2, which is 8, and assign that to I. So I has a value of 8 now. We're going to go into this 4 decider here again, and we're going to do our next repetition, which is our fifth repetition. So we're going to come down here, we're going to print 8, go across here, we're going to add 8 plus 2 to get 10 as a value of I. Once we have a value of 10 here, we're going to go in here, and we're going to do our last repetition, which is number 6. So we're going to go down here, print the value 10 to screen, go across here, take 10 plus 2 is 12, assign that to be the value of I, and go into this diamond shape here. Once we're done the diamond shape, we're going to recognize we have done 6 repetitions, or we've done 6 repetitions of the for loop. And we're going to say, let's now exit from here. And the program ends. So when we think about what we've printed to screen, we printed 0, 2, 4, 6, 8, and 10. So it took us 6 loops to print 0, 2, 4, 6, 8, 10. So with that, we can now start thinking about this as a for loop, or for a given number of repetitions, do this thing, right? So for being the for loop, this number of reps, do these processes. So let's go find out how we can do that in MATLAB now. So let's take a look at how we're going to do this in MATLAB. So over here, what I have is I've got a for loop syntax. So the for loop syntax begins up top here with the statement for, open parentheses, and then inside of those parentheses is the looping criteria. So this is the looping criteria. And what we're going to do is we're going to say we want to loop 6 times. So we're going to loop for the first loop, second loop, third loop, fourth loop, fifth loop, sixth loop. So we'll take a look at how to do that in a second, but the loop criteria from our prior problem was loop 6 times. Inside of the loop is the process we want to repeat. So remember, what is it we were repeating when we did this loop? Well, we were printing to screen, and then we were also adding a value of 2 to the current value of I and updating the value of I. So down here in this process code, we're going to have 2 processes. One of them is going to be an output process, which is going to be printing to screen. And then the other one is going to be an increment process where we take I and add 2 to it and reassign it back to the value of I. Once we've done 6 loops, we're going to end this for loop. And that's the end statement down here. So let's turn this into some MATLAB looking code. And let's take a quick look at how that flowchart turns into a simple MATLAB code where we have repeated processes. So here, we're going to start off our program with I equals 0. That is an input to the program. We're then going to loop over a number of loops. So I'm going to create a variable called loop number, and it's going to go from 1 to 6. So I'm going to have 6 loops. It's going to start at 1. It's going to go to the second loop, the third loop, the fourth loop, the fifth loop, and the sixth loop. It's really interesting to see that this is actually a vector. And this vector has values 1, 2, 3, 4, 5, 6. So the for loop here is going to march over the 1, 2, 3, 4, 5, 6 values in the vector and perform these steps inside of the for loop each time it goes through that element of the vector. Over here we have an output, so hopefully this is something that you recall. So I here is just going to print the I value into the screen. And then here we're going to take I and we're going to add 2 to it. So I plus 2, and we're going to reassign that back into the value of I. So when we begin the loop again, the I value has been updated. So you can imagine that this goes kind of like this in a flowchart way. And then when we get here, we just loop 6 times within these processes here. And then after 6 times, we continue to the next step of the program, which in this case is the end of the program. So let's take a look and see this in MATLAB. So here we are in MATLAB. Just quickly open up a new script like this. And then what I would like to do inside of this new script is to just essentially do exactly what we were planning to do, which is let's start off with the input to the program. And in this case, the input to the program is I equals 0. What we're going to do next is we're going to create a for loop. And in this for loop, we're going to use the same formatting that we used for the previous one. So we're going to say for loop number equals 1 to 6, like this. So we're going to do 6 loops, remember? MATLAB automatically indents the next line for us, which is awesome, right? So that's really nice. It keeps our programs nice and arranged. And I'm going to say here, I is going to be an output. And this is going to be a process that's repeated. So I could actually explicitly write repeated process. And I'm going to say I equals I plus 2. And this is going to be also an output, right? Which is a repeated, let's do it like this, process. And then at the end of this loop, I'm just going to type the words end. Whoops. End. There we go. So let's run this. We'll call this our for loop example 1. So for loop ex1. And then when I run this, what we can see is that the I values through this are listed, right? So I've got all kinds of I values flying on screen. So one of the really helpful things to do is to pause the loop so you can see what's going on, especially when you're learning how to do for loops. So let's clear our command window here. Let's hit run. And what we can see is when we pause that for loop, it's going to stop after those commands. So we start off with I equals 0. So that's printed out to screen as the first I equals 0 here. We then get I equals 0 again because we printed I out to screen. Then we added 2 to the current value of I. So I is now a value of 2. So let's hit enter. And what we'll see now is the I value printed out to screen here is 2. We add 2 to it and we get 4. So if we wanted to simply print out to screen 0, 2, 4, 6, 8, 10, what we would do is we would come in here and suppress the first line and we would suppress the second line of output. Let's just hit CLC here. So if you want to stop this program, you can press Control-C, then hit CLC, and I'm going to hit run. And what we should see now, when we run this, is we should see the different values of I. So I equals 0, 2, 4, 6, 8, 10. And then when I press enter again, it should be all done. So what we can see is if we wanted to print out to screen counting by 2s, we've been able to create a for loop to do that. One of the things I would suggest as you're learning for loops is to create those flowcharts. Those flowcharts are really, really useful. The other thing I would suggest using is this pause function here. So this pause allows you to see what's going on in the loop. When you're done, you can actually turn off the pause and then just use the for loop as is, so it doesn't actually stop each time. So that's a quick little example for loops. So what we're going to do now is we're going to actually go into a little bit more complicated for loop. So let's go try another one. All right, so the second for loop example is a little bit more complicated. What I'm going to say is we have last video, we talked a little bit about this idea of sin x being a process inside of MATLAB that is a calculation to create the value for sine of x. So here what you can see is a Maclaurin series for the approximation of the value of sine x. So if you're given a value x for sine here, you can approximate it through this series calculation. So this sum from k equals 0 to infinity will converge to the value of sine x within the area of convergence, or the radius of convergence. And the expression is basically you're going to take negative 1 to the k divided by 2k plus 1 factorial, and then you're going to take x to the 2k plus 1 as an exponent and multiply it by that. And you're going to add each of these terms. So let's just take a quick look at how this can be turned into a for loop MATLAB calculation. So there's going to be a few steps in this process, but bear with me, it's worthwhile, and you're going to see the power of the for loop in terms of this calculation. So if we look at this, one of the first things I would suggest doing is writing out this series, which is a series of repeated processes. So this process here is repeated each time we add a term to the series. And what we end up doing is we get individual terms. So x cubed over 3 factorial with a negative sign, x to the 5th over 5 factorial, plus dot, 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 dot. So what I'm just going to quickly show is that this is a repeated process. So in the first loop of this process, we're going to set k equals 1. And k equals 1 is going to give us a value from this equation of x. When we do the second loop, k equals 2, when we plug in k equals 2 here, we'll be adding a negative x cubed over 3 factorial. When k equals 3, aka you plug in 3 into the k's here, you're going to end up with x to the 5th power over 5 factorial. So the third time we do that loop, we're going to add this additional term here, this third term, to the other two terms that you've already added together. So this process here is going to build the approximation of sine x by adding a new term every time we perform that loop, right? So the loop here, or the repeated process, is to add the expression here for the kth loop. Hopefully that makes some sense. So just as a recall here, the for loop syntax is you have a criteria, then you have some code, and the code inside of the for loop is repeated. So let's try, I'm going to say, why don't you pause the video here in a second and give it a try to see if you can code up or write the code on paper, what this code would be for a sine approximation at a location x. All right, so we're back here. Hopefully you had a chance to take a look at this. What I want to do now is go over my solution and then code it up quickly. So here I create an initial variable, or an initial input, which is the Maclaurin sine series value is equal to 0 to begin. So remember, we're going to start off with a value of 0, and we're going to update that value by adding a new term to it every time. So if I start off with a value of 0, I'm going to go in and loop a number of times to approximate the sine by adding a new term to it each time. So this is similar to counting by twos, but in this case, instead of the new term being 2, we're going to increment by a different value that is defined by the sine series that we showed you. So taking a look at this, I'm going to say we're going to go from k equals 0 to 10. We're only going to take 11 terms, so the 0th term, first term, second term, up to 10th term. We're going to calculate the new term each time, right here. And once we calculate that new term in the series, we're going to add it to the previous approximation for sine to get an updated value for sine. So why don't we go give this a try in MATLAB. So here we are in MATLAB. let's create a new script and let's try and give this a go of creating our sine approximation calculation. So at the beginning here, we had input, and the input was mc_sine equals 0, right? So the Maclaurin sine is equal to 0. We then said, let's use a for loop to calculate the updates to the approximation. All right, so what we're going to do is say for k equals 0 to 10, right? So we're going to increment from 0 to 10, or we're going to do 11 loops here, right? Start with the 0th loop, first loop, second loop, third loop, fourth loop, etc. Or 0 loop, 1 loop, 2 loop, 3 loop, 4 loop, 5 loop, 6 loop, 7 loop, 8 loop, 9 loop, 10 loops. So it'll be 11 different loops, right? Where the k value goes from 0 to 10. Here we're going to get the new term is equal to, and this is where it's going to get a little bit complicated, it's going to be -1 to the kth power, right, divided by, and in this case it's going to be factorial, and I'm just going to keep on writing here, and factorial is 2 times k plus 1, right, that's my division, multiplied by the x value, all to the 2 times k plus 1 power, right? So all I've done here is written the actual expression that I have in my example. Then what we're going to do is mc_sine, right? So Maclaurin sine equals Maclaurin sine plus this new term, like this. And then after this, I'm going to type end. And then at the very end of this, I would like to see what the value of Maclaurin sine is. So before we hit run here, let's remember what we were trying to calculate. We were trying to calculate the sine of x. It looks like we're missing an x input for this problem. So we don't know what x is. So why don't I take x here equals, and let's calculate this at pi over 10, right? So let's take x being at a location pi over 10. And at this point, we've got a for loop that is going to approximate the value of sine using a Maclaurin series by adding a new term to each of the sine approximation every time we go through this loop. And we're going to do this loop 11 times. So why don't we go ahead and see what we get for an approximation. So here we go. I'm just going to make it a little bit more compact. So take out the enters here. There we go. And this is going to allow me to go up here. And I'm going to run this code. And we're going to call this code approx sine, like this. I'm going to hit enter. And the approximation for sine, you can see that we've added new terms each time. There's all kinds of things going on in that loop. But we're going to say that we approximated the value of sine at pi over 10 equals to 0.3090. So let's just take a sine of x and see if it's also equal to 0.3090, and it is, which is great, right? So sine of x is equal to 0.3090 right there. And if we run our approximate sine code, we get 0.3090. It might actually be interesting to see down here, we could write error equals Maclaurin sine, and we're going to take the exact sine value, so sine of x minus the Maclaurin sine. And I'm going to say this is the approx val right here, so the approximation value. I'm going to suppress my outputs to screen on all of these other parts of the code here, so that when this runs, it's only going to output the approximate value of sine and the error to that approximation. So let's hit run. And what we can see is that the approx value is 0.3090. The error for this approx value is 5 times 10 to the negative 17. So we've actually done a pretty good job here. We could explore how many terms are required to get a reasonable accuracy. So we could say, let's do 5 loops, and you can see that the error is still really, really small. So that's kind of neat. The other thing we might want to do is we might want to change the value of pi, or sorry, the value of x. So let's do pi over 20 here and see if that has any impact. Well, we still get a very low error. It changes the value right there, right? So that value for the approx value of sine of x has changed. So in changing these small things, we might actually think that it might be better to do this using a function. So what I'm going to suggest right now is you take this code right here that we've just created for approximating sine and turn it into a function that has inputs equal to x and the number of terms, and the outputs are going to be equal to the error as well as the approx val. And I would like you to call this function, remember we used function name, fname equals approx sine. So I'm just going to comment these here so that we know exactly what the target is. So we've written this code now. How do we turn this code into an actual function in MATLAB? So this should be a form of retrieval because last video we talked about functions. So I'm going to let you go ahead and give this a try. So pause the video and do some retrieval. Okay, so hopefully you had a chance to do some of that retrieval. Let's give this a try inside of MATLAB to see if we can create a function that has these properties. So I'm going to first comment out this x equals pi over 20 because that's going to become an input to my function. Up here, remember, when I type function, it's going to create a function with outputs equals the function name and then the inputs. And remember, one of those inputs was x and the other input was n terms. So here we go. We've got our function call definitely started really good here. The other thing that I'm going to have is the outputs are going to be the approx val and the error, right? So by thinking about it as outputs and inputs and what the process is, we can create this function really, really quickly. So the outputs for this function are this. The inputs are x and number of terms. And as we scroll down here, we want to essentially come here and do n terms as the final ending point, but -1 because we want to have this start at 0. So n terms -1 is going to be the correct number of added terms to this sine series. At the very end here, we have approx val equals mcsine and error equals the sine of x minus mcsine. So here we've created a function. We save the function as that name, and then we can copy this function header up here down to here. So here I am in MATLAB, and I'm going to now say the sine of x is pi over 10, and the number of terms is 10. Let's see what happens. We get the sine of x approx value correctly, and we get an error that seems appropriate, so things look like they're going well. I can then say, let's change this to pi over 20, and let's use 3 terms. And if we take a look at that, we get an approx value and an error. So what's really neat about this, and it was the same as what was really neat in the last video, so this was hopefully some cool retrieval practice, is we've been able to create a complicated function process now over here. So this whole function here had inputs and outputs, so it's a process. Once we built that function, we're able to create an internal process set that had the input of 0 for the initial value of your sine from Maclaurin series. We then did a loop where we calculated a new term on that series each time we went through the loop and added it to the previous value. And we did this for the number of terms that we wanted to look at. We then calculated the value and the error from that value. And now that it's a function, we don't have to worry about it anymore. We can come down here to our command line and we can apply any version of this. So we can actually say 3 times pi divided by 7, and we're going to use 300 terms. And we take a look at this, what we can see is the error is super small. There's the error. And the approximate value is calculated appropriately. So hopefully this has been a pretty cool demonstration of the power of for loops through a function that calculates the approximate sign. So with this, let's go back and do a little bit of a summary. So let's end off today's video with what is it we were trying to learn and what did we actually learn. So identify when processes repeat. So whenever we see a pattern in a process or in a set of numbers or in a system, it's likely that there's going to be a repeated process in there. So counting by twos, series solutions, seeing stuff just repeat over and over and over again, or scanning through a system of things, right? That's a repeated process. That repeated process is something we want you to be able to identify. So be on the lookout for them. The second thing we talked about was the for loop syntax, which is for, and then inside of the parentheses was the criteria for looping. And then we had the processes we were going to repeat. And then we had an end statement that closed off the for loop. And then the for loop implementation, we did 2 examples today. So counting by twos and the sign series approximation. So between those two, hopefully that's a good starting point where you can draw those flowchart diagrams and look at the loop part of that flowchart diagram and really zone in on what's happening inside of that loop. So hopefully that's a bit of a learning outcome recap. Until next time, do retrieval, try some practice problems, check and see where you understand things, and practice those things that you might be struggling with a little bit. All right, we'll see you next time.